Okay, to determine the average speed from 1 second to 3 seconds, we're going to find our slope. So we're going to do s of 3 minus s of 1, all divided by 3 minus 1. So I'm going to figure out s of 3 and s of 1 first from the equation. So I get s of 3 to be 1,602. I get s of 1 to be 1,474. I'm going to subtract those on the top and divide it by 2. So I get it to be 64 feet per second. For part B, they're asking you for the instantaneous speed. That is meaning to find your derivative. So let's find the derivative of the function. So that's going to be negative 16 times 2 using the power rule. I get the derivative as negative 32t plus 128. I plug in the 1 second for the time, work it out, and I get 96 feet per second. Part C is asking you to find the time required for the silver dollar to reach the ground. All right, this one I need to go ahead and graph it on the calculator. So you're graphing the original function, and you're going to see where it's crossing on the x-axis. So I needed to make my X window a little bit bigger for the X max. I made it 20, and I see that it's crossing on the X-axis right here, and it's specifically the time for 14 seconds. So that's the time for it to hit the ground. And then find the instantaneous velocity when it hits the ground. Well, I'm going to use my derivative again, and this time I'm going to plug in 14 for the time. And I get that to be negative 320 feet per second. What is the maximum height that the silver dollar will be? Well, that is again graphing it and trying to figure out where the top of the graph is. Then I do my second trace button, which is the calculate button. I do my left bound and my right bound on the top of my curve, left bound, right bound, and then for the guess, you press enter also. And I get my maximum height to be 1,618 feet.